Okay, we're back, and here's the general form I was building up to in the last few videos. And I guess this would be appropriately called the vertex form, let's say, of a quadratic equation. We know it's quadratic because this x minus h term gets squared. And if you actually squared that out, you get an x squared term. So we know it's quadratic. It doesn't have x cubed or anything higher. And it's not just x, it has the x squared, so it's quadratic. So here are just several cases of what this general form does. And I hope you realized in our last video that the vertex can always be found by looking at just these two numbers right here, hk. Whatever this number is, whatever this number is. If you have your equation in this form where you have x minus some value here, then whatever that value is tells you where the location of the vertex is on the x-axis. This tells you the location of the vertex on the y-axis. Let me just go ahead and label this vertex form. I'm not sure if that's what everybody calls it or not, but it makes a lot of sense to me. So right here I have some graphs, and I wrote some things down there at the bottom just to give you a little indication. If you have something in this form and you have a value for h and k, the vertex is located over here at hk, or h for the x, k for the y, where both of those things are positive. Okay? And the curve is facing upward, that is, it's a smiley face. If a is positive, this guy, and located over here if h and k are also positive values. If you look at the one just to the right of that, h is still a positive value, and so we just locate that vertex there at hk, both being positive, and this time a is negative, so we have a downward thing, or a sad face. If a is negative, we have a sad face. And that makes kind of sense emotionally too, right? Negative, sad, something like that. Okay. Now, the graph down here, I'm showing, again, I'm calling it hk, but this time h is negative. So a case like that would be if you had a plus there, you need to force it to be a minus to technically be in this vertex form. So x minus a negative number, would look something like this. It would be a shift of the vertex to the left. And when I say shift, I'm always referring to a shift from the center, a shift up, a shift down, a shift right, a shift left. So if your h is a negative value, it's a shift left. Okay? If k is positive, it's a shift up. And in this case, a is positive as it's going upward. Here the curve is going downward, or it's a sad face. So I can say right away that a must be negative. This is a shift left and a shift up. That means h is negative and k is positive. On the last piece I have here, from the center, it's a shift right and a shift down. So h and k are positive. H and a are positive because it's a happy face and it's a shift right. It's a shift below the x-axis, which makes k negative. So for example, let me just throw one out there, totally randomly. Suppose we had something like this. And I'm not going to put the actual values, I'm just kind of guessing. Okay. 2 x minus 3 squared plus 5. Let's say we had something like that. Then without putting the actual values, I can tell that hk is 3, 5. So the vertex is in the first quadrant, 3, 5. I can tell from this that it's going up. I'm not sure how steep, but let's just say something that looks like that, generally. Okay, so I'm not going to put any numbers to it, but just to indicate I know exactly where this is. It's at 3, 5. And I know it goes up because a is positive. If I had another example, let's just keep similar a, but let's say I had x minus negative 3 instead, quantity squared plus 5, okay? Normally you would see that as a plus 3, right? But you have to force it to have this minus in there so that you can tell whether this guy is positive or negative. So if there's a plus to start with, like this, x plus 3 squared, you force it to look like that, and now it matches the vertex form. And I can say, okay, I know that I've got an hk of -3 for the x and +5 for the y. This is still positive, so it's going up. And I don't really have space to show that, but something like that, and I'll just plunge right through the equation. So stay tuned. I'm going to get into the general form of the standard form quadratic equation and compare it to this form, and we're going to figure out a way to find the vertex using the standard form quadratic equation.